Good morning, algebra class. This morning I wanted to do a short review of exponential functions and the different parts, and then we're going to take a look at 3 examples of word problems where you need to create the exponential function and answer a question with it. So the first thing, this is the general equation that we have been using for exponential functions. Remember that the a is the initial value. And the initial value is always our starting point. What do we have to begin with? The b is our growth or decay factor. So this is our growth or decay factor. And remember, the way we know that something is growth or decay is what that number is. We need to know what that number is. If it is between, if b is between 0 and 1, or a fraction, or a decimal, in other words, then this is decay. It means your number is going to get smaller and smaller as x gets larger. Or your answer, y, will. If b is greater than 1, it can be have a mixed number, so 1.5, 2 and a third. It could be a whole number, 3, 4, 5. Anything that's greater than 1, that is going to be growth. And one other thing that I wanted to review with you was that when we are finding that growth factor, we also have something called the growth or decay rate, okay? And b equals 1 minus the rate, okay, where r is the rate of growth or decay. Okay. And b equals 1 plus r if we are talking about growth. Now I wanted to review that. We are going to be using all of those ideas and principles to do a few word problems today. So we're going to do 3 word problems together, and then I have some homework for you that is very similar to these. So let's take a look at the first one that I have here. Suppose 10 animals are taken to an island, and then the population of these animals quadruples every year. Find a function to model this situation. How many animals would there be after 6 years? Well, the first thing that we need to do is remember that our function is y equals a b to the x. And then we need to know what is our initial value. Our initial value is 10 animals. So that is going to be y equals 10. Now you'll notice up here, these are all problems that give the growth factor. Remember, the growth factor is b. Tomorrow we're going to look at questions that give the growth rate or the decay rate, and then you'll need to find the function from the rate. These are a little bit easier because they are giving you the factor in the question. Suppose 10 animals are taken to an island, and then the population of these animals quadruples. Means it multiplies times 4 every year. Now, something that I always have you do, and I want you to do for these problems, is to define what x is. X is the number of years. So we have our function or our equation that models this situation. We start with an initial value of 10 animals. It quadruples every year. So now I want to answer this question. How many animals would there be after 6 years? You will have y equals 10 times 4 to the 6th power. This is where we're going to grab our calculator. Okay, let me clear my window. We're going to start always, remember, with the exponent. So 4 to the 6th power times 10. And you're going to probably be using a different calculator than the one I'm using. And if you are, you may have to enter that in just a little bit differently. But the population of animals will be 40,960. After 6 years. Let's take a look at the next question. Suppose 20 rabbits are taken to an island. The rabbit population triples every half year. Find a function to model this situation. How many rabbits will there be after 2 years? Okay, now this one's a little bit different because it's not happening every year, but we are still following the same model. Y equals AB to the X. Y equals 20 rabbits initially. The B is our factor, remember, our growth factor, and it triples. So that's going to be a 3. But it happens every half year. Now if X is the number of years, again, because we don't talk about things in terms of half years, we talk about them in terms of years. That means for every year, this is going to happen twice, 2 times. So instead of an X up here, I'm going to put 2 times that X because it'll happen twice every year. So let's take that information and solve the question that we have here. How many rabbits will there be after 2 years? We will do Y equals, put an A there, it should be 20 times 3, 2 times 2 years. Y equals 20. Wow, I can't seem to write 20. 20. 3 to the 4th power. And again, we're going to grab our calculator. 3 to the 4th power times 20. Y equals 1,620 rabbits. Okay, hopefully that makes sense. Now this last one is a little bit different yet, and we're going to go ahead and work through this the same way we worked through the other ones. Suppose an investment of $10,000 doubles in value every 13 years. Actually, this should say 10 years. It was a typo on my part. How much is the investment worth after 50 years? So we're going to start with Y equals AB to the X. Again, our initial investment, our initial value is 10,000. So that's going to go where the A is. It's doubling in value. So that's a 2. Every 10 years. Now, if X is the number of years again, this is only happening once every 10 years. The way we would write that is X and divide the number of years by 10. I know that looks weird at first, but trust me, it's not difficult. So this is our function. We're going to take this over here and we're going to do 10,000. How much is the investment worth after 50 years? 2. I'm going to put a 50 over 10. 50 divided by 10 is just 5. So I'm going to grab my calculator again. You go do 2 to the 5th power times 10,000, which is $32,000. Hopefully that makes sense to you. The hardest part about these really are the exponents and figuring out, am I multiplying? Is it happening more during the year than just once? Or is it happening only after a few years have passed? So hopefully that helps you, and I will see you soon.